Okay students, now let's move to the next type of differentiation. Before we move on to the next type, let us try to revise try to recollect what are the types we have already finished. Okay, the first one, the problems based on chain rule. Second, the problems based on inverse trigonometric function. The next one, implicit functions. Okay, then after implicit function, log differentiation, that is function to the power function. Fifth one, infinite series, and the sixth one, that's the last topic, it's called as parametric differentiation. So these are the 6 types we already studied: chain rule, inverse, implicit, log, and infinite series, and the last one is parametric. Without knowing chain rule, you think I can solve all this? Never. Now without knowing chain rule and inverse, I cannot simplify some problems in inverse. Without knowing the first 3, I cannot do this one. And without knowing the first 4, I cannot do this. And without knowing the first 5, I cannot do this. Just look at the link between them. So one topic is linked to other. If you know the previous topic, you can do the next topic quite easily. Now, like that, we have the next topic called as you notice in EPL, we have something called as differentiation of one function with respect to another function. We call it as differentiation of function with respect to another function. You will not understand so easily if I just keep explaining the theory part. So I will explain with an example. So let's consider the first problem. They said that differentiate sin x with respect to root of cos x. Differentiation of sin x should be done by with respect to root of cos x. The easiest method, give a name. Let's call it as first function as u. So let me take u is equal to sin x and v is equal to root of cot x. Just notice. Now this is just similar to our previous topic, that is parametric differentiation. Their x and y they used to give. Now here I am giving the names for these two as y, okay, u and v. Now what is that I need to find? I need to find differentiation of u with respect to v. Differentiation of sin x with respect to root of cos x now will be modified to differentiation u with respect to v. So how to write differentiation of u with respect to v? It is simply written as du by dv. It is not du by dx now. Du by dv, differentiation of u with respect to v. What is the formula? Like the parametric differentiation, du by dv can be written as du by dx by dv by dx. A simple thing. So to do that, what should I do? First, let me take u, right? Differentiation of u with respect to x, du by dx. Differentiation of sin x will be cos x. Now, similarly, we have v. Let us differentiate dv by dx. First, it's in the form of root x, and then for cos x. Sorry. So differentiation of root 1 by 2 root x multiplied by differentiation of cos will be minus sin x. So what we got it here should be replaced here. So du by dv will be, now du by dx is cos x, and here in the denominator minus sin x by 2 root of cos x. Differentiation is done. We have substituted. The rest is simplification. What you can do is, if you want, you can just write down cos by sin as cot x, and root of cos, 2 root of cos x can be shifted to numerator. So still if I want minus 2 root of cos x, this is shifted to numerator, and cos x by sin x, cos x by sin x will be cot x. So differentiation of one function with respect to another function. An easy procedure, just similar to the parametric differentiation what we have studied. Let's go to the next second problem. There are not many problems of such kind, okay, but it's an important one. Okay, now let's consider the second one. They said differentiate tan inverse of 1 minus 2x by 1 plus 2x with respect to root of 1 plus 4x square. So your procedure remains the same. Okay, just a second. Okay, fine. Now, first thing, let me just give a name for this. U is equal to tan inverse of 1 minus 2x by 1 plus 2x. And the next one, second function v is equal to root of 1 plus 4x square. So let's find out du by dx and dv by dx. Students, you have to observe one thing here. What is here? If I differentiate directly, first thing I should differentiate for tan inverse 1 by 1 plus x square. Then quotient rule for this. It's a much time consuming one. But if you apply, if you just remember, there's a direct formula actually. Now, there's a formula in the inverse trigonometry. Once again, we will study later on. So remember, tan inverse x minus tan inverse y can be written as tan inverse of x minus y by 1 plus xy. This you will study in inverse trigonometry function. So time being, please make a note of this. So if I use this formula, okay, now what I got here is the right hand, similar to the right hand. So tan inverse of 1 minus 2x by 1 plus 2x simply can be written as tan inverse of 1 plus tan inverse of 2x. We will study this formula later on in inverse trigonometric functions. Please do not worry. Okay, so the numerator, the value of u simply can be written as tan inverse of 1 plus tan inverse of 2x. We will be studying this later on in the inverse trigonometric function chapter. So let us differentiate du by dx. Tan inverse 1, it's a constant, so it will become 0 plus tan inverse x 1 by 1 plus x square. Tan inverse is over. Now differentiate for 2x. Differentiation of 2x will be 2. Now look at v. If I differentiate that, dv by dx, what is the outermost one? Root. And the next one, 1 plus x square. So 1 by 2 into root of 1 plus 4x square. Differentiation of root x. Multiplied by differentiation of 1 will be 0 and this will become 8x. You got du by dx, you got dv by dx. So write the formula. Du by dv can be written as du by dx by dv by dx. So for simplification, please refer the EPL, you can find it. Okay, there is one more problem in this topic. There are not many problems in this topic. If you want to make perfect in this topic, please look at the home exercise problems. So the next one, they said differentiate sin inverse of 2x by 1 plus x square with respect to tan inverse x. The method remains the same. Let's give the name. So let's call this function as u and this one as v. So give the names for these two. So inverse, not to start directly, simplify. I will go for a substitution here. Let me consider x equal to tan theta, then u is equal to sin inverse of 2 tan theta by 1 plus tan square theta. Any students who's not thorough with the basics of trigonometry definitely will find it difficult. So my suggestion, practice the formulas, keep practice the formulas from trigonometry also. We will not going to do anything, it will be retained as it is. And this you notice, sin inverse of sin 2 theta. What we have written here is sin inverse of sin, can be cancelled. So the remaining is 2 theta. If x equal to tan theta, then theta equal to tan inverse x. So this will be 2 tan inverse x. This is u. Now differentiate with respect to x. Du by dx equal to 2 multiplied by 1 by 1 plus x square. Differentiation of tan inverse x. Now what is v? V is tan inverse x. Differentiation of v is going to be what? 1 by 1 plus x square. Now we have done both actually. Now final thing is to find the value of du by dv, that is du by dx by dv by dx. So substitute both and simplify. So that's all the problems based on differentiation of function with respect to another function.